Hi guys, this is notes for Unit 4, solving quadratic equations solved by factoring. So the method that we are going to go through today is factor by grouping. Here are the steps on how the process goes. The first step, we have to make sure that it is in standard form, ax squared plus bx plus c. Then we multiply a times c, and find two numbers that multiply to a times c that add to the b value. Once we find that, we rewrite the problem by splitting the b values, and then we group the first two terms and the last two terms. We then divide each of the terms by the GCF, and we know we did something correct if our parentheses match up. So in this example, x plus b and x plus b. That is our first step. Once we factor something, then we can use the zero product property. And what that says is that if we have two things being multiplied equal to 0, that either the first parenthesis or the second parenthesis is also equal to 0. So what this means is once we factor the equation, we're going to set them equal to 0 and solve. So let's look at some examples. Example 1, first we're checking to see if this is in standard form. So it is in standard form. Now we're checking if we can take out a GCF. Well, there's no numbers that can go into 6, 7, and negative 3. So we go on to the next step of taking our a times c. Well, a times c is 6 times negative 3, which is negative 18. And then our b value is 7. So we need two numbers that multiply to negative 18 but add to 7. Okay? So those two numbers would be 9 and 2, where the 2 is negative. So 9 times negative 2, or 9 minus 2, gives us the corresponding answers we're looking for. So that means instead of writing 7x, I'm going to write 9x minus 2x. So 6x squared plus 9x minus 2x minus 3 equals 0. Notice how we just expanded our b term. Okay, then we group our first two terms. Okay. So I'm taking the GCF out of the first parentheses. So I can take a 3 from 6 and 9, and I can also take an x since they each have an x. So when I divide 6x squared by 3x, I'm left with 2x, and 9x divided by 3x gives me 3. And I want my parentheses to match, and the only difference right now is those negatives. So I'm going to take out a negative 1 from each, and I'm left with 2x plus 3 equals 0. Okay. That means my two parentheses are 3x minus 1 and 2x plus 3 equals 0. And then using the zero product property, I know I can take each of them separately and set them equal to 0. So that means I'm going to add 1 to both sides, and I get 3x equals 1. Then divide by 3, and I get x is equal to 1/3. That's my first answer. The other one, I'm going to subtract 3, and I get 2x is equal to negative 3. Divide by 2, I get x is equal to negative 3/2. That's my second answer. Example 2, notice how this, even though it's in standard form, I'm missing a value, and that value is the c value. So when I'm given only the a and b value, I can skip all those steps and just go straight to taking the GCF. So the GCF that I can take from here is going to be a 6x. So 6x, which means I'm left with x minus 4 equals 0. Notice how I could just write the parentheses around the 6x, and now I have a parenthesis times another parenthesis equals 0, which means I can set each of the parentheses equal to 0 separately. So 6x equals 0 and x minus 4 equals 0. Well, this implies that x is equal to 0 when I divide by 6, and this implies that x is equal to 4 when I add 4 over to the other side. Let's look at number 3. Number 3, notice how this is not in standard form. So I have to take everything that's on the right and I need to move it over to the left side because this has to equal 0. So that means I'm subtracting x and adding 9. So I have 4x squared minus 11x minus x plus 9 equals 0, which simplifies to 4x squared minus 12x plus 9 equals 0. Then I do my a times c, which is 4 times 9, which is 36. Okay. And then my b value is negative 12. Okay, so I need two numbers that multiply to 36 but add to negative 12, and that would be negative 6 times negative 6 and negative 6 plus negative 6. So that means instead of negative 12x, I'm going to expand it using those negative 6x's. Then I'm going to group the first two and the last two and take out the GCF. So the first one I can take out a 2x, and I'm left with 2x minus 3. And in this one, I can take out a negative 3, and I'm left with 2x minus 3. Because remember, I want these to be the same. So that's why I knew that I had to take out a negative 3 in order for that negative 6x to become a 2x. Okay, equals 0. So I'm left with 2x minus 3 times 2x minus 3 equals 0. Well, notice how both of these parentheses are the same. So this tells me that I'm going to have only one root, only one answer here. So I just do 2x minus 3 equals 0. And if I solve for x, I get x is equal to 3 halves by adding the 3 over and then dividing by 2. Number 4, notice how number 4 looks like one we've done before. It has the a and b value, but it's missing the c value. So that means I just go right ahead and start taking out a GCF. So I can take out an x, and I'm left with x plus 8 equals 0. Well, that's the same as saying parentheses x times parentheses x plus 8 equals 0. So I can set each of them equal to 0 separately, and I get x is equal to 0. Already have my answer here. And x plus 8 equals 0, which implies that I get x is equal to negative 8. That's my answer once I subtract the 8 over. Number 5. Remember, my first step is to see if it's in standard form. Well, yes, it is in standard form. Now I'm going to check if I can take a GCF out. So I'm asking myself, is there a number that can go into 4, 7, and negative 3? Well, there is no number besides 1, so that means I do not take out a GCF, and I go straight to doing my a times c method. So a times c is 4 times negative 3, which gives me negative 12, and my b value is 7. So I need two numbers that multiply to negative 12 but add to 7. And if we can't think of this on the top of our head, we can write out all the factors of 12. So we have 1 times 12, 2 times 6, and 3 times 4. Well, 3 times 4 seems like it would be a good choice to choose because if we add that together, we would get 7. However, if we were to multiply this together, we would get a positive 12 and not a negative 12. So what this infers is that this equation is non-factorable. Okay? That is different from saying no solution. Okay? This does have a solution, we just cannot find it by factoring. So we say this is non-factorable. Well, remember, we learned other methods in order to find the root. And the other method we learned was the quadratic formula. So if something is not factorable, then you go and you use the quadratic formula. Remember, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I label my a, b, and c, my a is 4, my b is 7, and my c is negative 3. So plugging everything in, I get x is equal to negative 7 plus or minus the square root of 49 minus 4 times negative 3 all over 8. Which means I have x is equal to negative 7 plus or minus the square root of 97 over 8. And then I need to check if this 97 can be reduced by doing the prime factor tree. Well, if I start dividing that 97 by all the prime numbers that I know, starting with 2, I'll notice that none of them give me an answer. So this tells me that that square root of 97 is already as reduced as it can be as a radical, so this is our answer. Okay, on the back, we're doing the same thing. We have to first see if this is in standard form. And we notice this says 4x squared equals. So we know it's not in standard form, so we have to take the right side and move it over to the left. And we do that by subtracting the 4x and subtracting the 120. So I have 4x squared minus 4x minus 120 equals 0. Now that it's in standard form, I have to see if I can take out a GCF. Okay? Well, I can because there's a number that divides 4, 4, and 120, and that number is 4. So if I take out a 4, I'm left with x squared minus x minus 30 is equal to 0. Okay? So now my A value is 1, my B value is negative 1, and my C value is negative 30. So if I do A times C, I get negative 30, and my B value is negative 1. So that means two numbers that multiply to negative 30 but add to negative 1 is going to be negative 6 times 5, or negative 6 plus 5. So I have 4 parentheses x squared minus 6x plus 5x minus 30 is equal to 0. I still am grouping my first two terms and then taking the GCF out of each. So in the first parenthesis, I can take out an x and I'm left with x minus 6. And in the second parenthesis, I can take out a 5 and I'm left with x minus 6. Okay? Which means I have x plus 5, x minus 6. I bring down that GCF of 4 equals 0. So then I have x plus 5 equals 0 and x minus 6 equals 0. Well, this implies that x is going to equal to negative 5, and this implies that x is going to be equal to 6. Well, we can't forget about the GCF in the front, so we're going to take our answers and multiply it by the GCF of 4, which means our actual answers are x equals negative 20 and x equals 24. Okay, next question. Okay, on this one, again, we have to put it in standard form by moving that negative 6x over. So we're going to add 6x squared. So I get 15x squared plus 33x plus 12 plus 6x squared equals 0. Well, I need to combine my like terms here. So I get 21x squared plus 33x plus 12 equals 0. And then I see if I can take out a GCF, which I can. I can take out a 3. So if I take out a 3, I'm left with 7x squared plus 11x plus 4 equals 0. And so my A times C is 7 times 4, which is 28. And my B value is 11. So I need two numbers that multiply to 28 but add to 11. And those numbers would be 7 times 4, or 7 plus 4. So that means I have 3 parentheses 7x squared plus 7x plus 4x plus 4 equals 0. Separate my first two terms and my last two terms. And then from the first one, I can take out a 7x. I'm left with x plus 1. And in the second one, I can take out a 4, and I'm left with x plus 1. So I have 7x plus 4 times x plus 1, and then in front of everything I have my GCF of 3 that I'm going to bring down and set it equal to 0. So this means I have 7x plus 4 equals 0, which implies that x is equal to negative 4/7, and x plus 1 equals 0, which implies that x is equal to negative 1. Well, I got to still multiply both my answers by my GCF, so I have to multiply them both by 3. So that means my actual answer is x is equal to negative 12/7 and x is equal to negative 3. Two more examples here, and these examples are real-world problems. So it says, what is the value of the larger base in the trapezoid below if the area of the trapezoid is 32 square units? So it gives us the formula for a trapezoid, area of a trapezoid, but part of it got cut off, so I'm going to fix that right there. It's supposed to be 1/2. Okay? So looking at our trapezoid, it's telling us in our formula that we're going to have base 1 and base 2. Okay, I'm going to go ahead and label this bottom one base 1, and this top one here, I'm going to label it base 2. And then our height is already labeled for us, and that is our x. Okay, and remember, it wants us to find the value of our larger base. So our larger base in this case is going to be b2. Okay, so let's go ahead and set it up. So I have 32 is equal to 1/2 height, which is x, times b1 plus b2, so plus x plus 2 plus x plus 6, and then we need to simplify. So we have 32 is equal to 1/2 x times 2x plus 8. I just combine like terms. And then I'm going to distribute the 1/2 x in, and I get 32 is equal to x squared plus 4x. And then I want to put this in standard form, so I'm going to have to move this 32 over to the other side by subtracting that 32. And so I get x squared plus 4x minus 32 is equal to 0. And then I do my a times c method, which gives me negative 32. And then I have to add that to b, which is 4. So I need two numbers that multiply to negative 32 but add to 4. And those numbers are positive 8 and negative 4. So I would rewrite this as x squared plus 8x minus 4x minus 32 equals 0. I would separate my first two terms with my last two terms. And in the first one, I would take out a GCF of x, and I'm left with x plus 8. And in the next one, I would take out a negative 4 because I want to have another x plus 8 to match. Which means I have x minus 4 and x plus 8 equals 0. So if I set the first one equal to 0, this implies I get x is equal to positive 4. And then the next one equal to 0 implies that I get x is equal to negative 8. Well, remember, we are dealing with a real-world problem that's talking about measurements and distance. Well, since we're talking about measurements and distance, we cannot have a negative distance. So this cannot be an answer, which means that our x value has to be 4. But remember, it's not asking us to find x. It's asking us to find the largest base, which we titled b2. So b2 is equal to x plus 6. Well, we know x is 4, so 4 plus 6 gives us 10 units. That is the length of the largest base. Okay, last question over here. It says, what is the value of x for the rectangle given below if the area of the rectangle is 26 square units? So we know that the area of a rectangle is length times width. So let's go ahead and name this one length and this one width. And we already know the area is 26. So 26 is equal to 2x plus 5 times x minus 2, length times width. Well, since we have two binomials being multiplied by each other, that means we need to do the FOIL method. Okay? Remember, if you need help on the FOIL method, you can go look at some of my other videos, specifically ones from Algebra 1, to recall what this is, because I am just going to move on ahead. So we have 26 is equal to 2x squared minus 4x plus 5x minus 10. And I want to move that 26 over to the other side because I want to have my equation equal to 0. So I have 2x squared minus 4x plus 5x minus 10 minus 26 equals 0. I'm going to combine my like terms here. So I get 2x squared plus x minus 36 equals 0. Okay. Then, let's see. Then I have to do my a times c. So a times c is that 2 times negative 36, which gives me negative 72. Yeah, negative 72. And my b value, which is 1. So I need two numbers that multiply to negative 72, but give me positive 1. And those numbers would be 9 and 8, with 8 being negative. So 9 times negative 8, or 9 minus 8, which gives us that positive 1. So I have 2x squared plus 9x minus 8x minus 36 is equal to 0. I do my factor by grouping, and I look at my parentheses to see where I can take out a GCF. So in the first one, it looks like I can just take out an x, and I'm left with 2x plus 9. And in the second one, remember, I want to take something out from this negative 8x in order to give me 2x, because I want my parentheses to match, which means I'm going to take out a negative 4, so I'm left with 2x plus 9 equals 0. So that means I have x minus 4 times 2x plus 9 equals 0. So I have x minus 4 equals 0, which implies that x equals 4. And then I have 2x plus 9 equals 0, which implies that x is equal to negative 9 halves. Since this is a real-world problem and we are talking about measurements and distance, we know that we can't have any numbers that are negative, so that negative 9 halves is not going to be an answer, which means our only answer here is going to be x equals 4, where that 4 is representing the units of that rectangle.